morning, sir. My name is Nandini, CSC B section, and the subject name is Probability and Statistics, and subject code is 234G1A05A8, and today my topic is chi-square test. First, we are moving to the outline of chi-square test, introduction and problem, and finally conclusion. First, we are moving to the introduction to the chi-square test. Chi-square test. If I equal to 1, 2, 3 and so on, n is a set of observed frequency, and I in the sense I equal to 1, 2, 3, and so on, n is the corresponding set of expected frequencies. The chi-square is defined as chi-square equal to sigma of O minus E whole square divided by E, with n minus 1 degrees of freedom in the short form DOF. Chi-square is used to test whether the difference between observed and expected frequencies is significant. And then chi-square distribution is used as follows. Goodness of fit formula is chi-square equal to sigma O minus E whole square divided by E. And the second type is independence of attributes. Next we are moving to the problem. The number of automobile accidents per week in a certain community are as follows. The given frequency in a problem is 12, 8, 20, 2, 14, 10, 15, 6, 9, 4. Are these frequencies in an agreement with the belief that accident conditions were the same during this 10-week period? Give the detailed explanation and calculation. Next, we are moving to the steps in the chi-square test in a solution. In step 1, define the hypothesis. We need to compare the actual or observed accident numbers with what we would accept if accidents were evenly distributed. Null hypothesis. Null hypothesis we can call it short as H0. Accident conditions were the same during the 10 weeks, meaning accidents occurred at a steady rate each week. Alternative hypothesis. This is shortly called as H1. Accident conditions were not the same, meaning some weeks had significantly more or fewer accidents than expected. And then step 2. Calculate the expected frequency is done in step 2. If accident conditions were the same each week, the number of accidents should be uniformly distributed. The total number of accidents over 10 weeks, this is get by sum of all the frequencies in a given problem. That after the sum of all the frequencies is given in a problem, we get 100. Expected number of accidents per week E equal to total number of frequencies is divided by number of weeks. That E equal to, we can get 10. Thus each week is expected to have 10 accidents. Next we are moving to the step 3. Compute the chi-square test statistic. The chi-square statistic is calculated using the formula chi-square equal to sigma O minus E whole square divided by E, where O equal to observed number of accidents per week, E equal to expected number of accidents per week. That is 10 given in a problem. Now calculating the for each week by using chi-square test formula. Chi-square equal to 12 minus 10 whole square divided by 10 plus 8 minus 10 whole square divided by 10 plus 20 minus 10 whole square divided by 10 plus 2 minus 10 whole square divided by 10 plus 14 minus 10 whole square divided by. Likewise, we have to divide the all the values given in a problem. After subtracting and addition of all the frequencies, we can get 26.6. So the chi-square test statistic is 26.6. Next we are moving to the step 4. Determine the critical value. To decide whether the test statistic is large enough to reject the null hypothesis, we compare it to a crucial value or critical value from a chi-square table. Degrees of freedom DF equal to number of categories minus 1. Number of categories is 10. 10 minus 1 is 9. Significance level is considered as alpha. Alpha equal to 0.05, that is considered as 5%. Critical value for DF equal to 9 at alpha equal to 0.05 equal to by the basis of a square table we can get 16.92. And then step 5. Compare the test statistic with the critical value. Chi-square test statistic equal to 26.6, critical value equal to 16.92. Since 26.6 is greater than 16.92, we reject the null hypothesis. Step 6, conclusion. Since our test statistic is larger than the critical value, we have strong evidence that the number of accidents per week was not consistent over the 10-week period. Next, finally, the conclusion of the problem is the number of automobile accidents did not occur at a study rate. Some weeks had significantly more or fewer accidents than expected. This means that accident conditions were not same over the 10 weeks. This is about the chi-square test. Chi-square test. And finally, thank you, sir.